Okay. Have a look at the statement of the problem. It says 10 kg block is released from rest. Let's see. Here's a block. It's released from rest on the horizontal surface at point B, where the spring has been stretched a distance of 0.5 meter from its neutral position A. Let's understand this problem properly. This block is attached to a spring which is fixed here. Now, when the block was at position A, the spring, you see the blue color, that's the neutral position of the spring. That is, when block is at A, spring is unstretched. When I take this block at B forcefully, the spring gets stretched, and they are saying this distance between A and B is 0.5 meter. And they are saying neutral position A means when block is at A, spring is not stretched at all. Now they say if the coefficient of kinetic friction between the block and the plane is 0.3, calculate the velocity of the block as it passes point A, This is the first part. And second part, what they say is the maximum distance to the left of A that the block goes, that they want to know. They have given K as 300 Newton per meter. Now understand the phenomena. See, when I stretch this from A to B and leave it, obviously B will start going towards left. It will pass position A. At that time we want to know the velocity, that's the part A. And it won't stop at A because it has velocity towards left, that is in left direction. It will go on. Spring will resist it. So at some point it will stop. They want to know where. Maximum distance to left of A that the block goes. Okay. What we do is we write our energy equation, which has been discussed in part 6 of this video series. Okay. Now, let's take B as position 1 and A as position 2, and let's look at the values. Left hand side is for position B, right hand side is for position A. Now, F into D is 0 because there is no external force. mgh is 0 at B because, see, we are going to take this line as reference. So, mgh is going to be 0 because the body is at reference level. Half mv square in position B is 0 because they have said that the block is at rest. And half kx square is half 300 is k into 0.5 square because, see, that is the distance by which spring is stretched. Now when we come to spring energy, what we have to remember is energy stored in spring is half kx square, whereas k is stiffness of the spring and x is the distance either stretching or compressing from neutral position. So from neutral position, this distance is given as 0.5. So that's why 0.5 square. Now look at right side, the position A. mgh is 0, same level. Half mv square, yes, because it has achieved some velocity. Half kx square 0 because when block comes at A, spring is unstretched. So x is 0. So half kx square is 0 plus 0.3 r into 0.5. Now, 0.3 r is frictional force because friction is mu r and r is the reaction and d is the distance 0.5. Now, in this simple situation like this, reaction r is same as weight. So, weight is 10 g and therefore, if I put it, I get v as 2.13. That will be the velocity of the block when it passes point A. Now, let's look at the second part. There are two ways of doing it. You can take position A as 1 and when it stops as 2. Alternatively, the way I have done it is, I take B as position 1 and when after passing point A when it stops, I take C as position 2 and between these 2 points, I try to write this equation. So, F into D is 0, same arguments as before. mgh is 0, same arguments. Half mv square 0, same argument, and then half 300.5 square is the energy at B. See, after all, there is no need for this term to change at all, because this is for energy at B, this is also for energy at B. Right hand side, that is at position C, mgh is 0, half mv square 0 because the block stops at C, half 300x square, where now you see we have assumed distance between A and C as x, and that is the distance the spring is compressed, and that's why we are calling it x only. And then we have friction into distance as 0.3 r is the frictional force, and x plus 0.5 because the block while moving from B to C has moved actually the distance of this 0.5 plus distance between A and C, x, so x plus 0.5. And now knowing r, we can easily work out x, though it's a quadratic equation, but that's not a big deal. You get x as 0.314 meter. That is the distance from A on its left where the block will stop. Okay. Look at the next problem. It says a block of mass 5 kg resting on an inclined plane is released. The block, after traveling a distance of 0.5 meter along the inclined plane, hits a spring of stiffness 50 Newton per centimeter. Find the maximum compression of spring, assuming the coefficient of friction between the block and the inclined plane as 0.2. Okay, situation is similar, except that the block is on incline. And by the way, this angle is 30 degree. Not mentioned here, but this angle is 30 degree. Alright, so what they are saying is block is released from here. Here is the spring. This red is a neutral length of the spring. Because block comes and hits here, it goes down and it compresses the spring by x. So what we are going to do is take this as position 1, and when it stops as position 2, and write energy equation as before. So that will be F into D, which will be 0. Now you see, we'll take this position when you stop as a reference level. Then this position is this distance sine 30. So 0.5 plus x sine 30 is this height. That will be h, and mg is 5g. Then half mv square 0 because block is at rest, and half kx square 0 at this position because when the block is at this position, spring is untouched and therefore neutral, and therefore x is 0. Right side, when spring comes here, mgh is lost, so mgh is 0. Half mv square 0 because the body stops. Half kx square is half 1500 into x square, where x is the compressing of the spring. Note that we have taken k as 1500 just for the units. It's 15 Newton per centimeter. The rest of the things are in meter. So it's 1500 Newton per meter. So it's half kx square plus friction into distance. Distance is x plus 0.5. Frictional force is mu r. And mu is 0.2, and for inclined plane r will be 5g cos 30, and therefore if you put it here, you solve quadratic in x to get x as 11.5 centimeter. Okay, have a look at one more problem. A cylinder has a mass of 20 kg and is released from rest when h is equal to 0. Determine its speed when h is equal to 3 meter. The springs each have unstressed length of 2 meters. And k for the spring is given out here. Okay, position 1 and 2 are clear. Equation is regular. So we plug in the numbers. Fd0, no external force. Mgh, see I take 2 as a reference. So in position 1, obviously it is potential energy, which is 20g into 3. 3 is the height. Half mv square 0 because it doesn't have velocities at rest when it is at this level, and at this level the spring lengths will be 2. Springs are unstretched, that's what they have said, when its length is 2. Therefore half kx square is 0. On the right side, mgh is lost. Half 20v square exists. Half kx square is half 40 is the spring constant. 1.6 is the stretching of the spring. So this you get from Pythagoras. The length of the spring is 2 square plus 3 square under root, that is 3.6. That is 1.6 beyond 2, and therefore 1.6 square, and 2 spring, that's why twice. And here there is no friction, so friction into distance is 0. So only unknown is v, which is not difficult to find, and we were asked the velocity. So this is how you are using this one single equation in solving the kinematics of particle problems. Thank you.